Next up, we have 3 selections from the demo pit. Every day we're going to bring up 3, 4, 5 companies from the demo pit. We're going to put 3 minutes on the clock for the demo pit companies. And if you're in the demo pit, be ready for anything. OK, next up, big round of applause from the demo pit for Carbon.
Hi, I'm Rosanna, this is Dan, and we're the founders of Carbon Robotics. Human history has been punctuated by key inventions, inventions that changed the course of history. From the first mechanical computer to the tools that led to the agricultural and industrial revolution. In our lifetimes, we've seen 2 of these, the computer and the internet. They have connected the world, and they have catapulted humanity forward. Robotics is our next frontier, and its linchpin is the robotic arm. So robotic arms are the ultimate universal tool. They can do anything a human arm can do, and often better. They are essential in manufacturing, but now we see them pouring coffee, going to space, performing surgery. The problem is that they are expensive, they are dangerous, and they're an absolute nightmare to use. And that's where we come in. We've created Cassia, our kick-ass, trainable, intelligent arm. And she solves all 3 problems. So robotic arms today, the cheapest industrial arm you can get is over $20,000. Cassia has the capabilities of an industrial arm, but the price of a laptop. That is 10 times cheaper. Cassia can move over 1 kilogram anywhere within a 1 meter work envelope with sub-millimeter precision. She has a carbon fiber frame, brushless DC muscles, and more raw processing power than most of the computers in this room. Now, obviously, an arm that is powerful enough to do what you want can also do something you don't want. So the arm has to be safe. But the truth is that even the best collaborative robots out there have to hit you to know where you are. At Carbon, we've invented a brand new sensor that can detect a human up to 20 inches away in any direction from anywhere on the arm. We build this right into Cassia's housing, so it is the safest robotic arm that has ever been made. So now let's say you have the arm. Well, you'd probably like it to do something, which means you're going to have to interface with something like this. With Cassia, we've made it incredibly easy to train. To get started, you can just physically guide the arm through a routine, and it plays it back perfectly. We also have apps for controlling in more complicated ways, and you can integrate with other devices as well. So you do not need any special skills to get started. The opportunity for this is huge. According to SRI, a sub $5,000 robotic arm is the most important target in robotics. It is the tipping point where massive adoption becomes inevitable. And it's a lot like computers 30 years ago. They were tools that were industrial, and they were in labs and industry, when they became personal and ubiquitous. So it's hard to overstate that impact. Take biomedical research, which is still mostly done by hand. Not only do researchers waste hours manually pipetting, they make mistakes, the kinds of mistakes that can jeopardize results and cost lives. With Cassia, you do not make these mistakes. They can focus on the design. In the US alone, more than 16 million people are unable to live independently. For people who have limited mobility, you can attach a robotic arm to wheelchairs or station around the house so they can regain their independence. And even in manufacturing, only 10% today is actually automated. The other 90% is human labor, and often in grueling conditions. But it doesn't have to be this way. Cassia can do the tasks that no human was born to do.
Let's hear it for Carbon. From our judges.
What have you guys done that's been able to bring the price down relative to what's out in the market, and why can't they do that?
Yes, there's a few things. The first is that we just benefit from the environment of the cost of sensors coming down. So anything that goes into a mobile phone, anything that goes into a drone is now significantly cheaper. But what we've done, which is pretty special, is we use a lot of software and sensors to make the commodity parts perform like precision parts. So the expense with robotic arms today is that the components that they use are so expensive. And these are high precision parts, and we're able to offset that with software and clevers.
So I'll take the next one here. It sounds like you were applying your CATIA to any particular market, and I've heard of other arms that are designed for particular applications. And what's your process for going to market?
Yeah, so we are starting with prototyping. It's what we've been doing for years, and these are the people who have been with us from the beginning of starting the project, and they're always the people who are sort of mildly interested in what you do, and then those who grab it out of your hands, and prototypers are those people. So these are small businesses, they're engineering services, and they're individuals. And so for them, it works right out of the box. But one of the biggest problems in robotics is actually that you do have these silos. You have the robot for this, you have the robot for this, the robot for this. And so we're also building a developer platform that lets anyone who could, let's say, be a mobile developer today, they could be a robotic developer tomorrow. And that's just not possible today.
And considering the various applications you can use with this particular robot, how does that vary across train levels? So is it harder to train it to do surgery versus helping out an elderly patient, et cetera, et cetera?
Yeah, so it really depends on the application. So in the simplest way, you can physically guide it through routine, and that is going to help for people who want to use it for film. That's sufficient for them. They put a camera on it, they guide it through the motion, voila, it did what they wanted. If you want to go into the deeper levels, that's what we're building out with our SDK, is to make sure that we have those correct abstraction levels, that it's really, really easy if you're starting and you have a simple task, but you can get into the details if you need to. So it depends.
Thank you.
Do you see that your sort of roadmap looks a lot like scaling this particular arm, or do you actually see this becoming a much larger project that has giant machines? I mean, I know it's hard to say because you're just here and this isn't impressive to be where you are, but what's sort of the long-term goal?
The long term is that ultimately there will be a robotics platform that makes it as easy as you have with mobile development and with web development, and they should all speak the same language, they should be standardized, and they should be easy for developers to integrate. And so that's what we're excited by.
Awesome.
I see what you're doing in a way to be what the MakerBot did, which is nobody really knows what 3D printers were going to do, and they just put it out there, and people started to find some use for it. There were still very high-end ones that did metal and really complex 3D printing, but it feels like this is an enthusiast crowd, and they're going to tell you what to do with your product. Is that right?
It's a combination. So we've learned a lot as we've been out and talking to people. There are some people who, today, it solves an immediate need for them, and they know exactly what they're doing with it. But then there are also people who are very enthusiastic, and they want to explore.
All right, let's hear it for Carbon Robotics.